Introduction to Pipe Stress Analysis by Carl Napper of Ductgrove Limited. This is an introduction to pipe stress analysis and why it is carried out. The most important reason pipe stress analysis is carried out is safety. It is also a legal requirement in most countries to design pressure systems that are safe. This is achieved by designing a code-compliant system and ensures piping systems are designed safely. Computer pipe stress analysis techniques can be employed for this purpose. There are also financial savings to be made using material sizes, thicknesses which are correctly specified. Also using correct pipe support spans and ensuring load-sensitive equipment lasts for its expected design life. There are many piping design codes which are used throughout the world. Listed below are just a few. Design considerations. When designing a piping system, thermal expansion, dead weight, live loads, seismic, surge and wind loads all need to be considered. Other considerations which affect the piping system are the connected equipment, i.e. vessels, heat exchangers and columns. Also, rotating equipment, pumps, turbines and compressors. All these need to be considered during the piping design and analysis of a system. Pipe support loads can be determined by pipe stress analysis. This information is then provided to the civil and structural section. This information is then used to enable the structural elements to be designed. Pipe displacements and thermal expansion should be noted. This information is then used to ensure you have a clash-free system. Not all piping systems require analysis. A medium to large project may have many lines which can be designed and constructed without a stress analysis review. These are engineered to suitable pipe specifications and the lines are adequately supported and stay within the sustained stress for the chosen piping code. Ductgrove Limited has an industry standard selection chart which filters the piping systems that require comprehensive computer analysis. Ductgrove can provide a stress critical line list review for any projects which will determine which lines require analysis. This review then defines a scope for the stress analysis requirements of a project. The diagram shown indicates the stress critical selection flowchart, which can determine which lines require analysis and the level of criticality assigned to that particular line. Information required for pipe stress analysis. To perform pipe stress analysis and to determine the piping criticality class, the following information is required. The line number specifying the duty and service of the piping, the design temperature, design pressure, the operating temperature, operating pressure, test medium, line sizes, and insulation type and thickness. Also, the piping material and grade, valve types and other information of rigid fittings, T-type connections and any corrosion allowance. A P&ID is normally required, which indicates the line number, the valve types, any relief information, equipment and package information defined by interfaces on the P&ID. Piping layout drawings and 3D model plots are also required to show the piping configuration. Piping layout drawings or 3D model plots are also required. Pipe support locations are not always required. These can be specified by the analyst. If a 3D model has been used, a PCF isometric can be imported directly into the CESA 2 analysis program. Any stress isometrics must also consider existing piping up to a fixed point or two changes in direction, which have either a guide or some point of fixity. Importantly, load-sensitive equipment also needs to be considered during the analysis. Piping is normally connected to vessels, pumps, heat exchangers and tanks, which have equipment allowable loads. These are normally specified on vendor drawings or to a particular standard. Any special system requirements should also be identified early in the design stage, i.e. surge requirements for liquid lines, settlement data of large equipment or piping. Wind snow loads may also be considered during the analysis. Steam out is also a condition which should be considered during the analysis stage. A Ductgrove stress report would provide the following: the project title, the project number, an introduction to the task, design parameters, temperatures, pressures, etc., the material specification reference, load cases which have been considered in the analysis, and any methods which have been used for the analysis. There is a results summary which shows the highest code stress for both sustained and expansion stresses. There will be a conclusion, model plots, copies of isometrics used, annotated with stress nodes to match the analysis, loads and displacements of the piping system and its supports, and any additional calculation sheets or data sheets which are appertaining to springs or bellows, etc. Ductgrove have produced this set of guidance notes which indicates all the information which is necessary to carry out pipe stress analysis. Clients may use these guidance notes to collate standalone stress packages for analysis. If you have a piping system or a number of systems that require analysis, please contact one of our consultants with some basic details and we can provide a quote for the task or project in hand. Site visits may be required, however, in most cases this is not normally necessary. Thank you. For further details, visit our site at www.ductgrove.co.uk.